All right, guys, here's your review for your last exam, exam 4. Should be excited, you're almost done. So let's finish strong. Um, okay, and then you have your final right after this. So it's cumulative, so all of this stuff is important for the final as well. All right, so first, when you're integrating, if you have something like this, you need to rewrite it. So that's what this part is. It brought the 4 out. That's one of the rules, the scalar multiple rule. X to the 4 on the bottom is x to the negative 4 on top. And when you go to integrate this, you add 1, adding 1 to a negative number. If you're at negative 4 and you add 1, you actually go to negative 3. Then you divide by whatever you just got in this exponent. So simplify would be negative 4/3 x to the negative 3 plus c, or negative 4/3 x cubed plus c. Okay, secant squared, we just know that that's the derivative of tangent. So the antiderivative of secant squared is tangent, and sine goes to, when you're writing down a c, you change the sign. You're writing a c with the answer, because when you take the derivative of a c, you change the sign. So when you're going backwards, if your answer has a c, you flip the sign, which is the same as making it negative. Okay, so if we're going to find the particular solution, that just means you're going to separate, integrate. So 7x squared, take the antiderivative, add 1, divide by it. So 7x cubed over 3 plus c. And then I know when I plug in negative 1, I'm supposed to output 6. So plug in negative 1 for x, output 6. Negative 1 cubed is negative 1 times 7 will be negative 7/3 plus c equals 6. So add 7/3. When I'm adding 6 plus 7/3, it's like adding 18/3 plus 7/3, so 25/3. Okay, the width of each subinterval, well, you can see it goes from 0 to 1, and there's 4 of them. So if I take 1 minus 0 divided by 4, that means the width of each one is 1/4 or 0.25. The right hand endpoints are used to approximate, will it be upper or lower? Okay, so right hand, if the function is increasing and you do a right hand sum, it's going to be over, because if I look at this, for instance, which one is higher, the one on the left or the one on the right? The one on the right. So if I'm using that to make my height, the height of that rectangle is going to be a bigger approximation than the area just under the curve. So that's an upper sum. So if it's increasing, the right is upper and the left is lower, and vice versa for a decreasing function. Write a formula in terms of I that defines the right endpoints. Okay, so let's think about this. We always have delta x is b minus a divided by n. So we have 1 minus 0 over 4, so 1/4. And then we have the x of I, which each equals your a, plus delta x I. So a in this case is where we start, which is 0, plus delta x 1/4 times I. And then you find f of x I. So plug this in to the function itself. What is our function? It's this guy, the square root of 3 minus x. So it'd be the square root of 3 times 1/4 I. And then we're going to sum up f of xi times delta x. So we're going to sum up the square root of 3, and multiply, that'd be 3/4 I, times delta x, which is 1/4. We're going to sum that up from I equals 1 to I equals 4. So that would be our guy. Oh no, it says right endpoints. I forgot if we're doing, oh no, that's right endpoints. Left endpoints you go back with. So I need to double check and see if they want the sigma notation. If we needed to write out each one, it would be, it does say in terms of I though, so this would make the most sense. If we wanted to check it out, you would plug in 1 for I, so it'd be like the square root of 3/4 times 1/4. Then plus you plug in 2 for I, so it'd be the square root of 3/4 times 2 times 1/4. Then the square root of 3/4 times 3 times 1/4, and then the 4th. I just ran out of room. use the right endpoints and force orbitals to approximate the area of the given region. Okay, so that's basically what I was just doing. Now, if I didn't have to write it in terms of I would not. I always I go like this. I know it goes from 0 to 1. We're counting by a half. So 1/2, 1, that would be 3/4. Oops, this is a 1/2. Oh my goodness, 1/4. 0, 1/4, 1/2, 3/4, 1. The width of each of these subintervals is 1/4, so you pull that out front. And then left hand means you would use this one, right hand means you don't use this one. So we're going to plug in 1/4, so f of 1/4 plus f of 1/2 plus f of 3/4 plus f of 1. So you just plug these into the function, which you can in y1 type in the square root of 3x. And then you can actually type this in your home screen. You can type in 1/4 and then pull up vars, y vars, or you can push alpha F4 and pull up y1 and then put in 1/4 plus y1 of 1/2 plus y1 of 3/4 plus y1 of 1 and do it that way. Or you can find the square root of 3/4, the square root of 3/2, the square root of 9/4, the square root of 3, and add them all up and multiply times a 4. Left will be then lower. So if we're going to do the endpoints for the left one, you have to subtract 1. So same idea, delta x was b minus a divided by n. xi is a plus I minus 1 times delta x. Okay, so 0 plus I minus 1 times 1/4. And then f of xi, you plug in that. So the square root of 3 times I minus 1 times 1/4. And then you're going to sum up that square root of 3 times I minus 1 times 1/4 times the delta x from I equals 1 to I equals 4. And then if you actually find the answer, all you're going to do is have 1/4 and you're going to have f of 0 plus f of 1/4 plus f of 1/2 plus f of 3/4. You leave off that rightmost endpoint, which is the 1. So plug all of these guys into the function to get the heights, add them up and multiply times a 4. Okay, so you can see that we start at 0 and we go to 2. So we're just integrating from 0 to 2, the function itself 3e to the negative x. This one, so if it's in terms of y, we need to use the y bounds, so 0 to 2, and then just the function itself, because the left bound is just x equals 0. Okay, so this is the absolute value shifted up to and opening down. So up to would be this one. We're finding the area from -2 to 2. So that matches with this one here. Sorry, guys, I need to, oh, having a hard time breathing. Okay. Consider the following. Rewrite from 4 to 6, x minus 14 in terms of the integral. So we have this, and then minus 14 of those. So it would be this, the second one. Evaluate, okay, so then that would be 10 minus 14 times 2. So negative 18. Okay, evaluate the following 0 to 3, 3 to 6. So if we add them together, Our answer from 0 to 6 would be -1. So this gives us the integral. So if these match, you get this to this. So we're just adding 2 plus the -1. So that gives us 1. From 6 to 3, you just are flipping this. So you flip this sign. So that'd be +1. When these don't change, you didn't move at all. That's 0. 3 to 6, -5. You're just going to pull out the -5 and multiply times the answer. So -5 times 2 is -10. Okay, so if I take the antiderivative, I add 1. So adding 1 is like adding 3 over 3. So 4/3, 3/4. Add 3 over 3 here, so that's 5/3, 3/5. So then if I plug in my 0, I'm going to get 0. So then minus 3/4 -1 to the 4/3. So I got -3/4 because this would be +1. Then minus 3/5, -1 to the 5th cubed. Those are both odd, so that's going to stay negative. So this is going to get positive. So 3/4 plus 3/5. If I multiply this by 5 over 5 and multiply this by 4 over 4, I get 15 over 20 plus 12 over 20. So that gives us -27 over 20. Integral of sine is negative cosine. 9 is 9x. 0 to pi, so negative cosine pi minus 9 pi minus negative cosine 0 minus 9 times 0. Make sure you put parentheses when you plug in the second one. So -1 minus 9 pi minus -1 minus 0. So I get +1 minus 9 pi plus 1. So 2 minus 9 pi. And you can put this in Math 9 to verify your results. Okay, this one, we're going to integrate from 0 to this number right here. Sine, the antiderivative of sine is negative cosine. And then the fundamental theorem says you plug in the top bound and then you subtract what you get when you plug in the bottom. So cosine of pi over 3 is up here. That's 1/2. Cosine of 0 is 1. So I get 1 minus 1/2, which is 1/2. Let's talk about for a second. If I would have gotten -1/2, hopefully you'd recognize that doesn't make sense because it's not negative area. It's not below the x-axis. Find the area of the regions bounded by the graphs with equations. 9 plus root x would be like the cube root 1, 2, 3, 5, 6. Cube root shifted up here. X equals 0, x equals 8. So we're trying to find this area here. So we're just going to integrate from 0 to 8. 9 plus x to the 1/3. The antiderivative of 9 is 9x. The antiderivative of x to the 1/3, you add 3 over 3, be 4/3 with the 3/4 in front. Plug in 1, plug in 0. When we plug in 0, we're going to get 0. So we get 9 plus 3/4. 9 would be 36 over 4 plus 3 over 4, so 39 over 4. Okay, so u is the thing inside, so tangent, and the du would actually be secant squared. U here is this part. Derivative of this is 9x to the 8th. So we need to take the antiderivative of this. So, because we're trying to find f and they started with f prime. Okay, if I take the antiderivative of this, my u is 8x squared. My du would be 16x. So if I rewrite this, I would have 2x u squared, and then instead of dx, I'm going to write du over 16x. You're essentially dividing this by the derivative of this to figure out what goes in front. So you get a 1/8 because 2 over 16 simplifies to 1/8. Then take the antiderivative of that. That would be u cubed over 3 plus c. So we have 1 over 24th. U, plug u back in, 8x squared minus 20, q plus c. Then I need to plug in this point to figure out what c is. So it'd be 1 over 24th, 8 times 2 squared minus 20q plus c equals 10. So 4 times 8, that is 32 minus 20. So what is that? That is 8. I mean, no, not 8. That is 12 cubed. So I have 1/24th times 12 cubed. So this would go in there 2 times. So 72 plus c equals 10. So subtract 72. Negative 62. So your answer is this function here with your c solved for. I got negative 62. So I would write 1 over 24, 8x squared minus 20 cubed. And then instead of c, I write what I got when I solved for c, negative 62. It should work out that if I plug in 2 and simplify this, I get 10. Okay. What's the antiderivative of cosecant cotangent? It's negative cosecant because the derivative of cosecant is cosecant cotangent, negative. And then you divide by the derivative. So there's a 1/2. Negative 1/2 cosecant 2 times pi over 4 plus 1/2 cosecant 2 times pi over 12. That'd be pi over 6. Okay, so cosecant of 1/2 of pi over, okay. So this is 0, 1. So sine is 1, it's the reciprocal of 1, so it's just 1. Cosecant of pi over 6. Sine here is √3 over 2. So it's the reciprocal of that, so it'd be 2 over the square root of 3. So negative 1/2 plus 1 over √3, and you could simplify that. Okay, well, average value is a formula where you do 1 over b minus a, integral a to b of f of x dx. It's kind of like you're summing up all those values and dividing by however many there are. So we're going to integrate from 1 to e and put 1 over e minus 1. And then we're going to integrate 18 natural log of x over x. When you see this over x and ln of x, what you have to realize is that this is your u. Because what is the derivative of ln? It is 1 over x. That is the derivative, so it will divide out. If you solve for dx, so I have 18u over x, dx is x du, so these cancel. So you're really just integrating 18u. That'll be 18u squared over 2, which is 9u squared, and u is natural log. 1 over e minus 1 out front. So 1 over e minus 1, 9 natural log of e squared minus 9 natural log of 1 squared. Natural log of 1 is 0, natural log of e is 1. So it's just 1 over e minus 1 times 9. So this. Okay, find the particular solution we're gonna take the antiderivative. All right, so we see that square root and we see a constant on top and something squared on bottom, which means we need to think inverse trig. We have a number minus the variable, which means sine, okay? So I know the answer is arc sine u over a would be 5. D is just 1 in this case. And then we're going to integrate from, oh no, whoops, no we're not, it's plus c. And then we want to figure out what c is. When I plug in 0, this is to get pi. So let's talk about arc sine. This is saying what angle gives you a sine of 0. So this angle right here is 0, 1. This angle right here is 1, 0. It happens to be that 0 gives you a sine of 0. So this is actually 0 plus c equals pi. So c is pi. So your answer is arc sine, like y equals arc sine of x over 5 plus pi. Okay, for this one, we need to break apart interval because we can see the top function changes. So it looks like we're going from 6 to 7. The top minus the bottom. I always do top minus bottom. You can see the top is the curve. So the curve is going to be the cubic one minus the bottom. And then we would need to double that, since if it's only going to go, let us use from 6 to 7, you can see this happens to be symmetric. So you could actually take double this integral and that would give you the integral of the whole thing. Okay, the antiderivative of this would be t to the 8th because you add 1 and divide by it. So it'd be 2t to the 8th plus c. And if I rewrite this, that would be to the 1/8 power. And again, I have a whole video over exponent rules. So if you're confused about exponent rules, check that video out. You're going to add 1. So adding 1 is adding 8 over 8. So that becomes 9/8. Then you divide by 9/8, which is multiplying by 8 over 9. So 8 over 9 x to the 9/8 plus c. Remember, adding 1 is just adding a number over itself. The antiderivative of sine is negative cosine. The antiderivative of cosine is sine. It says check by differentiation. That means just take the derivative of this in your mind and see if you would get this. So if I take the derivative of negative cosine, I get sine. Derivative of negative 5 sine would be negative 5 cosine. Okay, x over 4 is a line with a slope of a fourth, like over 4 up 1. From 0 to 8. So it looks like it's the first one. Yeah, there's this one right here. All right, let's see. I have 3 integrals to deal with. So I have x cubed, which I see right here. I have just plain x, which I see right here. So what we're going to do is any scalar multiples can just come out front. So it's 6 integral 4 to 8 of x minus 1/10 integral from 4 to 6. I said 4 to 8. I don't know why. 4 to 6 x dx, x cubed dx. So I see that I had my x cubed right here. I have my x right here. So I have 6, 4 to 6 of x is 10, minus 1/10, 4 to 6 x cubed is 260. So that'd be 60 minus 26. So what does that give us? 26, so 34. Which would be down here. And as far as our answer, we have 6. This one. Okay, 0 to 5 is 17, 5 to 7 is 9, so 0 to 7, I would add these together. 17 plus 9. 5 to 0 means you change that sign. 5 to 5 is 0, and 0 to 5 with the 2 in front. You need to multiply 2 times the 17, so 34. You're just going to integrate this from 0 to pi. Antiderivative of x is x squared over 2. Sine goes to negative cosine. And we have pi squared over 2 minus cosine of pi minus cosine of 0. So pi squared over 2, cosine of pi is -1. So -1 is going to be a +1. That's 0, but that's -1. So I get pi squared over 2 plus 2. Seven x squared plus 1. Okay, so we're just going to integrate from 0 to 2, 7x squared plus 1. And again, you can put this in your calculator using Math 9. You could just type this in, okay? If you're going to integrate it by hand, you would do 7x cubed over 3 plus x, and then plug in 2. 0 is going to give you 0, so 7 times 8 is 56. (62 over 3). Okay, this one I take the antiderivative, and then this is a way to solve for c. Okay, so you take the antiderivative of this, so u is 8 minus x squared, so du is negative 2x dx. That divides out then, and so you're just integrating u to the 1/2. And so you add 1, that's adding 2 over 2, so that becomes u to the 3/2 with the 2/3 in front, plus c. Now I'm going to use this to solve for c. So you're going to plug in 2 and set it equal to 7. So 2/3, 8 minus 2 squared to the 3/2 plus c equals 7. 2 squared is 4, 8 minus 4 is 4, so we have 2/3, 4 to the 3/2 plus c equals 7. So this is the square root of 4 cubed. That's 2 cubed, which is 8. So 8 times 2 is 16, so 16 over 3 plus c equals 7. So subtract 16 over 3. 7 would be 21 over 3. So that's 4, 5, that's 5/3. So that means c equals 5/3. So that means your answer is this function right here. 2/3, instead of u, you're writing what u was. And instead of c, you write what c was, which we got to be 5/3. Average value, you just integrate 1 over b minus a to b, 32x to the -2 dx. Add 1, divide by it. So -1/4, 32, so that becomes -8 over x. So this is -8 over x from 4 to 8. So that becomes -1 plus 2, so 1. Zero to 1, top minus bottom. Okay, how do we know which one's on top? You pick something, and so like pick 1/2 and plug it in. If I plug 1/2 in and I raise it to the 4th, that's 1 over 16. If I put 1/2 and raise it to the 5th, 1 over 32. Which one is bigger? This one. So which one's on top is x to the 4th. So x to the 4th minus x to the 5th from 0 to 1. -1 to 0. So we're going to double it since they're just choosing those bounds for me. I'm going to use symmetry because these are the same. So 2 times this, or you could put the 2 inside. Top minus bottom, or just the function itself. So 7 xu minus x. So that's all for that one. I think that might be the end of the review. Okay. Work hard. Let me know if you have any more questions. I'm happy to help. You're almost done. Finish strong.